is Carly McAvoy, and I'm teaching the Lesson 10 Order of Operations for Math 064 today. Before I start talking about order of operations, I just want to talk about exponents and square roots to make sure that we all are on the same page with that. If I have something like this, 3 times 3 times 3 times 3, that means that I have multiplied 3 repeatedly, and I can use the shortcut notation for that. Keep 3 as a base, and I have 4 of those, so I would say that's 3 to the 4th power. The number that you're multiplying is called your base, and the number that the times that you multiply it is called your exponent. How I would multiply this is I would say 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So it's not 3 times 4, it's 3 times itself, times itself, times itself, because there's 4 of them. So 3 to the 4th power would be 81, not 12. So you just want to remember that when you have a power like that, it multiplies the number. So if I have 4 times 4, what number is the base? The base is 4. What number is the exponent? There's 2 of them, so the exponent is 2. The answer to that would be 4 times 4, or 16. So you multiply the number times itself. So that's what an exponent looks like. Let me show you this one. 1 to the 5th power looks like 1 times 1 times 1 times 1. A common mistake here is to get the answer 5. But what's happening is you have 1 times 1, which is 1, times 1, which is 1, times 1, which is 1, times 1, which is 1. In fact, I can multiply 1s all day, and I'm still going to get 1. 1 to the 912th power, still 1. So anything, 1 to any power is still 1. So you should be able to write a number in exponent form, or if they give you one like this, let's start with 3 because I just used that one. 2 to the 4th power, and ask you what is that in expanded form. Well, the 2 is the base, and 4 times is your exponent, so that would be the expanded version of that, 2 times 2 times 2 times 2. So that's an exponent. And the other thing I want to tell you, well, I'll tell you that after we talk about order of operations. We'll skip that for now. Let's talk about square roots. The square root of a number, you may have seen this symbol before. This symbol right here, or if I was to read that, that would be read as the square root of 36. This little symbol right here, that's called the radical. In 36, this is not a term that you would be tested on or anything, but it comes up, so I want to give you the number. The number underneath the radical is called the radicand. When you see the radical sign, it's asking you a specific question. What's the question that it's asking you? And it's asking you this. What number times itself would equal the radicand? That's the radical question. What number times itself would equal the radicand? So I want you to say this. Some number times itself equals 36. And that's what I want to know. What is that number that we could say some number times itself is 36? I know I can take 12 times 3 and get 36, but that's not the same number twice. I can take 4 times 9 and get 36. Again, not the same number twice. What's the number that times itself gives you 36? And that's 6. So the square root of 36 is 6. Okay. And then What about the square root of 25? The question is, what number times itself would equal 25? And that's 5. Okay? So when you're talking about a square root, you're looking for the number that times itself would be that radicand, that number underneath. So that's the basic idea of those. Then we're going to talk about order of operations, because every time you have a problem that's got more than one operation in it, let's say you have 7 plus 4 times, remember parentheses there means times, indicate times, 20 divided by 2 plus 1. There's a lot of different operations going on in that problem, into division, multiplication, addition. So in order to get that right, there has to be a conformity. We all have to agree in order of operation. And so the order of operations goes like this. Parentheses, exponents, multiply, divide, add, and subtract. So some people, in order to remember that, and I'm going to show you those written out in a second, in order to remember that, they use this little, what we call a mnemonic, that says, please excuse my dear Aunt Sally. And that's how they remember the order of operations. Please excuse my dear Aunt Sally. Now, let's look at these order of operations in a little more detail. So the order of operations, and I've got them typed out here, and you can write those down, and you can always pause and freeze the screen or whatever to get those written down. I'm going to read those out loud and talk about them. The first thing you do in order of operations is the parentheses. Parentheses, remember, are grouping symbols. Parentheses, brackets, braces, they all mean the same. If there is more than one set of grouping symbols, you work them from the inside out. And then exponents, second. Exponents and square roots are done at that same point. Even though we don't say square roots when we say exponents, we have to do both the exponents and the square roots at that point after the parentheses. If you have more than one exponent, you work from left to right. So you're going left to right, exponents and square roots at the same step. Multiply and divide. Work these from left to right, whichever comes first. Multiplication does not always come first. Sometimes you do division and then multiplication. That's one of the biggest mistakes that people make, is they always want to jump in and do multiplication before division. And I think it's just because of the way it's stated, multiply and divide. So people think, okay, I'm doing that first. But you should be doing whichever comes left to right first. And you're gonna make that mistake, and I'm gonna correct it. It's gonna happen, so just be ready for it, but that's what's happening there. And then addition and subtraction, same thing. Work these from left to right, whichever comes first. Addition does not always come before subtraction. Sometimes subtraction will come first and then the addition. But what I can say is that you always do addition and subtraction after multiplication and division. And if the person wrote the problem wants you to do the addition or subtraction first, they have to put it inside parentheses. So that parentheses says, no, go ahead and do this first. No matter what operation, we're going to do what's inside the parentheses first. Then the exponents, then the multiply and divide, and then the add and subtract. So remember, please excuse my dear Aunt Sally. That's the order of operations. If I went too fast and you didn't get a chance to write all that down, write it down. Then back it up and listen to me say it again, and just listen without having to write it down. Get it written down and listen to it so that the order of operations makes sense to you. And we're about to jump in and work a bunch of problems using the order of operations. Okay, let's do this one since it's up here on the screen. In the order of operations, say do the parentheses first. So what's inside the parentheses is a division and an addition. And division always comes before addition. So I'm going to do the division, and then I'm going to do the addition in there. What I want you to get in the habit of doing is writing the rest of your problem down, because you haven't done it yet. So just bring it straight down. But I am going to do 20 divided by 2 on this step, which is 10. Next thing I'm going to do is finish the parentheses. So I have 7 plus 4, and 10 plus 1 is 11. So what people want to do with the order of operations is skip steps, do steps in your head. Well, they eventually get harder, and this is something that people have trouble with in basic math, in Math 94, in Math 98, in Math 99. Every class I've ever taught, people struggle with the order of operations. The more detail you can show yourself, the less chance of making a mistake. So I strongly urge you not to skip steps. The next thing is multiply before we add. So I'm going to say 7 plus 44. And finally, I'm going to add 7 and 44 together, and that's going to give me 51. So using the order of operations, I get 51. If you do it out of order, you get a different answer. It's wrong. The idea is that I could be doing it here, somebody could be doing it in Zimbabwe, and we get the same answer because we follow the rules of math. So that's what I want you to do. Okay, so just a little reminder, please excuse my dear Aunt Sally. And remember that if we had our square roots, then that would be coming in at the exponent level. I have this whole page of these for you to practice, but truthfully, to get into Math 90, you don't have to be good at order of operations. That's something you get to practice when you're there. But it's good to know it and be able to kind of come in with a little bit of a head start. There's all kinds of problems on this page. I think 17 order of operation problems. I'm going to be changing the numbers a little bit so you can practice with me, and then you can go do a similar problem on the paper by yourself. So I'm going to number them, even though, again, this doesn't match if you printed off your sheet like you should have for order of operations. This is very similar, but not exact numbers so that you can try your own. So something like 30 plus 3 times 2. What would you do first here, the addition or the multiplication? You should be doing the multiplication first. So you have 30, and 2 times 3 is 6, so 36. Okay. Number 14 looks something like this. 7 times 8 minus 3 times 5. Getting a little droppy. What do you have in this problem? Well, you have multiplication, subtraction, and another multiplication. The please excuse my dear Aunt Sally's telling you that you always should be multiplying before you subtract. 7 times 8 is 56. 3 times 5 is 15. So you do the multiplication, you jump over, do the multiplication again, and then you subtract. Excuse me, that gives you 41. Number 15 is something like this one, 48 divided by 2 times 3 plus 7. Okay, you might want to pause and try these and then come back and see if you get them right. But here's the common mistake on this one. People love to jump over and do 2 times 3 and get 6 because they like to do the multiplication before the division. Think back to those rules of order of operations that we had up earlier. Multiply and divide, work these from left to right, whichever comes first. In this case, multiplication does not come first. If you look left to right, it's division, then multiply, and of course addition is going to happen after those two anyway. So I'm going to do this, 48 divided by 2, and that's going to give me 24. And then I'm ready to do the multiplication. So division came first, then multiplication. At the end, we're going to add. 24 times 3 is 72. And that you can do off to the side. You don't have to be able to do all this in your head. 3 times 4 is 12. Carry the 1. 6 and 1 is 7. 72 plus 7. Now you're ready to add those two together, and 72 plus 7 is 79. That's a common mistake one because people frequently want to jump over and do the multiplication first and then the addition. Why did I skip 16? Because I don't count very well, apparently. Let's see what 16 looks like. Looks like something like this: 3 plus 4, and in parentheses, 12 minus 6. Well, what you have here is addition, multiplication, a parentheses with subtraction inside. Once you have a parentheses, you have to do that first. Not when you have this over here. This right here, that's just an operator. That's telling you to multiply. What I'm talking about is when you actually have something inside the parentheses to do, you need to do it. So inside the parentheses, it's telling us to go ahead and subtract those two. So I did not change 3 or 4, but 12 minus 6 is 6. And now I'm ready to do which one, the addition or the multiplication. Always you're going to do multiplication or division before you do addition and subtraction. And so we have 3 plus 24. And 24 plus 3 is 27. Notice I'm not skipping steps, and it's not taking me forever. I just am not just going to skip those steps because it's important not to. I think I can squeeze 17 in here, and we can look at that one. 17 looks like this: 18 minus 6 plus 8 over 7 minus 2 plus 5. What does that mean when I'm saying over that? Well, I have a fraction, but that indicates what? It indicates division, which means I'm going to do the top, simplify that all the way. I'm going to do the bottom, simplify that all the way, and then I'm going to divide those two numbers. So you work the top and the bottom separately, and then divide them afterwards. On the top, I have subtraction and addition. That's what I have on the bottom, too. What I'm checking to make sure that you don't jump over and add before you subtract. Remember the rule for this is that addition and subtraction, work these from left to right, whichever comes first. So we cannot say that it should be adding first. It's left to right. 18 minus 6 would be 12. And I still have the plus 8. 7 minus 2 is 5, and I have a plus 5. Then I have 12 plus 8 is 20. And 5 plus 5 is 10. And now I need to divide 20 divided by 10. How many times does 10 go into 20? 2 times. So my final answer for that is 2. So 13, 14, 15, 16, and 17, your first 5 are simplified right there. All right, moving on to 18. Let's do this. Please excuse my dear Aunt Sally. It's nice to have those up as a reference as you're working and have them written down next to you or something. So let's say you have 12 minus 3 to the second power. Well, what I have here is I have a set of parentheses, I have a subtraction, and I have an exponent. Well, remember, parentheses come first, so whatever happens inside the parentheses you have to do first. So we're going to do 12 minus 3, which is 9, and then we're going to take the 9 to the second power. 9 to the second power is not 18. What is it? It's 81, because it looks like this: 9 times 9. There's 2 9s, so we're repeating 9 twice. When you repeat something twice, you're just multiplying it times itself. 9 times 9 is 81. So 81 is our answer to that one, number 18. Do inside the parentheses and then do your exponent after that. Okay. Got a whole other page of them. If you turn your sheet over, if you've printed them out the way you should have, you're going to see a whole second page of these, because it's nice to practice, because there's a lot of different little tricks and things that can come up. Okay, so number 19, we could do the square root of 121 plus 5 to the third power. Okay, this problem, I have square roots and exponents. Those are actually on the same level. Even though we just say exponents, it means square roots too. So we're going to do both of those, and then we're going to add afterwards. The square root of 121 is asking you this question: what number times itself would give you 121? You can experiment a little bit. There's a square root button on the calculator if you have one. You're welcome to try with that. But it turns out to be 11. So the square root of 121 is 11 because 11 times 11 is 121. And you'll get better at those numbers the more you work with them. And then we're going to do 5 to the third power. 5 to the third power is not 15. What it means is 5 times 5 times 5. You don't have to be able to do that in your head. 5 times 5 you might be able to do in your head is 25, and then 25 times 5. 5 times 5 is 25, and 2 times 5 is 10, plus 2 is 12. So 125. So we'll have 125 plus 11, which is 136. Simplify both parts and then add them together. All right, number 20. Okay, so I have something like 20 divided by 4 plus 30 divided by 6. That's the type of problem we have. We have two divisions and an addition. Of course, division is going to always happen before addition. Look over here at your order of operations. Multiply and divide is a step ahead of addition and subtraction. So we're going to divide each part, and then we're going to add the two parts together. 20 divided by 4 is 5, and 30 divided by 6, also 5. And then we're going to say add those two parts together, and that's going to be 10. Final answer. All right, 21. Kind of fitting them up there so you have several examples to look at once. 21 looks like 150 minus 3 times 13 plus 9. So I have a subtraction, I have a multiplication, and I have addition. And I'm going to work that in the right order, and that means I'm going to do the multiplication first. So I have 150 minus 39 plus 9. The next thing I'm going to do is subtraction, because subtraction and addition, whichever comes first from left to right. So we're going to do the subtraction, and then finally we're going to do the addition because it's the last one. 150 minus 39 is 111. You don't have to be able to do that in your head. You can do it off to the side and get the answer and then come back and put that in. Now 111 plus 9, that's 120. There's that one. All right. Number 22 looks like 2, 30, minus 6 plus 9 minus 1 to the third power. One of the things I'm looking for here is that you remember that when you have a number outside of parentheses, that just means to multiply. But you're not going to do that until you finish what's inside the parentheses. Inside the parentheses we have subtraction and addition. In this case the subtraction came first, so we would do that subtraction first. So we have 2. 30 minus 6 is 24, and I'm not going to do this yet because I'm going to take care of the parentheses first. 24 plus 9 is 33. What is 1 to the third power? Do you remember what I talked about when you take 1 times itself again, multiplying by 1 every time, you still get 1. So I have 2 times 33 minus 1. 2 times 33 is 66. Now I'm ready to do that. 66 minus 1 is 65. So 65 for that one. Okay, number 23. is 20 divided by 5 minus 4 over 7 times 3. When I'm saying over, that means that there's a division problem in there. Take care of the top first, take care of the bottom second, and then you divide those two parts. 20 divided by 5 minus 4 on the top. Well, we're going to do the division before we do the subtraction. 20 divided by 5 is 4. And on the bottom, 7 times 3 is 21. But on the top, I have 4 minus 4, and that's 0. So here's the moment of truth. Is that answer undefined, or is it equal to 0? Well, that answer is 0, because 21 goes into 0 0 times. So it's a 0 answer. If the 0 was under would be undefined, right? So this one equals to 0. 21 goes into 0 0 times. That's a tricky one. You got to remember about that. Okay, clear this. Moving on to 24. 24 looks like 4 to the third power divided by 6 plus 4 minus 6. Well, inside the parentheses first, and inside the parentheses the addition comes before the subtraction, so we're going to do the addition first. 10 minus 6, that's really good. It looks sloppy, so I just can't live with it. That is 10 minus 6, because we just combine 6 plus 4 to get to 10. Then you want to continue on. 10 minus 6 is 4. Notice I don't put the parentheses anymore. Once I've finished everything inside the parentheses, I don't really need them. 4 to the third power, what is that? Well, 4 times 4 is 16, times 4 is 64. 64 divided by 4. And so you can write that out as a long division problem, or you can do it in your head or whatever. But it looks like this. 4 goes into 6 one time, and 4 goes into 24 6 times, so the answer is 16. Remember, you can always go off to the side like I did right there and work out pieces that you need to work on. You don't have to do it in your head. But don't clutter up your problem doing that. Do that off to the side, then come back and put your answers in, because it gets really hard to read if you do all the calculations right there inside the problem. Okay, number 25. 25, something like this. 500 minus 3 times 7 times 4 divided by 2. Well, you've got a subtraction. That's going to happen last. 500 minus whatever. Inside the brackets we have that was 3 plus 7. I just want it to look like the one that you have. 3 plus 7 times 4 divided by 2. We're going to do inside. If you have more than one set of parentheses, you do the innermost and work out. So we're going to do 7 plus 3 first. So I've got 500, and then 3 plus 7 is 10. Okay, and then I've got 10 times 4 and divided by 2, but the multiplication came first, so we would do the multiplication first. 10 times 4 is 40 divided by 2. And 40 divided by 2 is 20. I'm just cutting 40 in half. And 500 minus 20 is 480. All right, so 480 would be the final answer. Number 26 looks like this. 7 times 4 divided by 2 times 3. This one's really tricky for people because they see all those parentheses and they say, well, don't we supposed to do parentheses first? So we should do the 7 times 4, then we should do the 2 times 3. The answer is that the parentheses in this case don't have anything inside them. Look inside the parentheses. There's a 7, there's a 4, there's a 2, there's a 3. There's nothing to do inside those parentheses. So all these parentheses are telling us is to multiply. And the rule for multiply and divide is left to right. So we should do this multiplication first because it's the first one I see from left to right. So that's 28. And here's where people want to jump in and do 2 times 3. But again, now if I look from left to right, what comes next? What comes next is 28 divided by 2. And not 2 times 3, but the division is next. Half of 28, cut it in half, you get 14. And then you multiply 14 times 3 to get 42. All right? And so that one is the one that people really have a hard time with. They want to do multiply, multiply, and then divide. You can't do that. You got to keep it in the order that I showed you. Okay, number 27. 5 plus 7 minus 4. People that start getting these right, they find them to be really fun because they're kind of like a puzzle and you got to figure them out. But there's good rules to follow, so if you follow the rules, then the puzzle's going to just work itself out nicely. On the top, and then on the bottom, and then divide. So I have 5 plus 7, which is 12 on the top. On the bottom, I'm going to do inside the parentheses first. 20 minus 2 is 18. Continuing on the top, 12 minus 4 is 8. On the bottom, 18 minus 18 is 0. What is this? Is this 0 or undefined? You should say undefined because the zero is under. Under is undefined. So this problem, because there's a 0 in the denominator, well, divisor I should say, we haven't really talked about fractions yet, but because the 0 is down there, then that makes that undefined. Okay. 28. Looks like 8 squared minus 4 minus 1 to the third. They're both exponents, but one of the exponents has a parentheses that you need to do first. So you always want to solve inside the parentheses first and then exponents. So we have 8 to the second power, and 4 minus 1 is 3 to the third power. 8 to the second power is not 16. It's 8 times 8, which makes it 64. 3 to the third power, 3 times 3 is 9, times 3 is 27. So that's 27. You take the number, whatever the base is, and you multiply the number of times that the exponent says. I'm going to subtract 64 minus 27 and get 37. And that's my final answer. Notice I did some work off to the side, but I didn't clutter my problem and I came straight down. Another thing that people do is they work it left to right, and when you do that, it's not as easy to look back and see exactly what was happening in the step above. I'm modeling the behavior that I would like to see you do. I want you to show your steps. I want you to put them directly one below the other because that's how people get the most answers correct. And we're all about getting those right. Okay, number 29, something like 19, plus 2, 4, or let's do 5 times 6 minus 2 times 7. I have addition, I have multiplication, I have subtraction, but I have most of the things inside the parentheses I'm going to start with. And remember, I wrote times, sometimes as a parenthesis, sometimes with a dot, so that you remember those are both meaning multiply. So 5 times 6 is 30, and 2 times 7 is 14. Finishing inside the parentheses, I have 19 plus 2 out here. 30 minus 14 is 16. Then I'm going to take 2 times 16, which is 32. 19 plus 32. And 32 plus 19 is 51. And again, if you don't know that, you can do it off to the side. 19 and 32. There's no rule that says all this has to be done in your head. In fact, don't. Because you're just inviting mistakes when you do that. How confident you are is to determine how much of this you do in your head. Some people are super confident and they shouldn't be because they make mistakes all the time. If you feel confident that your mental math is great, but you keep making mistakes and getting these wrong, that should be a red flag. Hey, you know what? Do this on paper. Your mental math isn't maybe as strong as you think it is, but as time goes on, it will get better. If you force yourself to do it on paper for a while, then you can start to take shortcuts. Okay, 25 plus 18 minus 12 plus 9. All I'm looking for here is that you remember that addition and subtraction are on the same step and you work them from left to right. So you're going to start out and add these two numbers. Again, if you don't feel confident, put them down and do them off to the side. This would be 43. The next thing is that we're going to subtract before we add here because we always go left to right with addition and subtraction. 43 minus 12 is 31. And finally, 31 plus 9 is 40. Okay, you had a whole bunch of examples of order of operation. Practice those, and when you get to Math 90, believe me, you're going to get to practice those again. So you'll have a lot of chance to do that because you don't ever finish with those. You keep doing those all the way through algebra, and it's an important thing to remember. Okay, you're ready. I'll see you next time for lesson 11.